Hey, what's going on, guys? Mr. Flores here, and today this video is going to start the section on matrices, which are the singular version is known as a matrix. Okay, and when we talk about a matrix, we're not talking about that movie with Keanu Reeves where he bent over backwards, dodging bullets and stuff from secret agents, but we're talking about the mathematical idea of a matrix. And in a mathematics, a matrix is an array. Well, I should say. Oops, why is it not typing? Okay. It really is a rectangular array of data formatted in rows and columns. Okay? So basically a matrix is just a rectangular shape of data that has rows and columns, and it can have numbers, variables, it can have a whole bunch of different things. All right, and a lot of times kids say, well, when am I ever going to need this? So basically a matrix, you know, I think you're watching this video on the computer. Yeah, so computers use matrices a lot, actually. For instance, let's say that you go on your computer and you go to your desktop and you find a picture of you and your friend, okay? When you have that little image of the picture on your desktop, it's an array or a matrix of data that's very, very small, okay? The second you double click the picture and it opens the picture and actually creates the image on your screen, a bunch of different matrices are doing all these calculations, thousands, millions of calculations in a matter of a second to turn that picture from a bunch of numbers or color codes to an actual visual image we can see with our eyes, okay? We're not going to do anything that's crazy like that because that's whole computer programming and software engineering, but that's what matrices are used for. They're used to organize data. Actually, Excel is a bunch of matrices, but it's kind of made a lot neater looking. Okay, so just to start off with a matrix, we're going to start off with being able to just read them. Okay, so we said that a rectangular array of data formatted in rows and columns. All right, the way we can remember rows go left to right, columns go up and down. Okay, so the way I remember that is that I remember that columns hold up they're basically pillars. They hold up balconies and stuff. Or you think of the Greek Parthenon, those are columns. The big things that go up and down. So columns go up and down. Rows go left to right. Okay. The way we read, or we basically write the dimensions of a matrix is the number of rows. So we have 2 rows by the number of columns. Okay. So this matrix is a 2 by 3 matrix because it has 2 rows and 3 columns. Okay. Hopefully that's pretty easy, pretty self-explanatory. So if we look here, now what I'm going to do is in this matrix, knowing the position of each number is very, very important. So really, the position is just where it is. So this is row 1, column 1. So this is R1, C1. Then if we go to row 2, column 1, and we're at 3, we're row 2, column 1. And it's really nothing crazy, okay? But being able to understand this is going to help you guys out a lot in a couple lessons when we do matrix multiplication, okay? But you basically just read it the row by the column. So 0 is in row 1, column 3. 13 is row 2, column 3, all right? Hopefully that makes sense. Hopefully it's understandable, all right? So let's see what we have here. All right. So let's see this matrix. There's 2 rows, then there's 1, 2, 3, 4 columns. So this is a 2 by 3 matrix. All right. So that's literally all you have to do when you're finding the dimensions of a matrix. You just count the rows, count the columns, bada bing, bada boom. That's it. All right. The next thing we're going to talk about is equal matrices. Okay. So equal matrices. which basically is exactly what it says. It's two matrices that are equal, okay? So I'm going to draw one matrix like this. Now let's say that's 3, 12, x, and 2y is equal to 3, 12, 7, and negative 10, okay? What we need to do is we need to find, and this is where kids love it, x and y, all right? So if we look here at our matrix, we know 3 is obviously equal to 3, 12 is obviously equal to 12, x is equal to 7, okay? And 2y is equal to negative 10. All right? Well, we know this because these two matrices are equal. Therefore, every corresponding part of the matrix of each matrix must be the same. So 3, if it's 3 in row 1, column 1, it must be 3 in row 1, column 1. If it's 12 in row 2, column 1, it must be 12 in row 1, column, or row 2, column 1. So we know that x must be equal to 7, and 2y must be equal to negative 10. All right? So you're just going to solve these just like you normally do. So we need to get the y by itself. And we know that y is equal to a negative 5, x is equal to a 7. All right? In a nutshell, that's all equal matrices are. Okay? The only thing you have to make sure of is that if in order for two matrices to be equal, they have to have the same blank. And I'm going to show you that now. Okay. All right, so right now it says that this left matrix is equal to this right matrix. Right off the bat, we know that that is not true. Okay? And the easy factor is, look at the dimensions. The dimensions of this one is a 2 by 3. The dimensions of this one is a 2 by 2. Therefore, a 2 by 3 cannot equal a 2 by 2, so this one would be no solution. The second giveaway is that in row 1, column 1, this says 3 is equal to 4. Is 3 ever equal to 4? I hope not. So therefore, we know that it's no solution. All right. And in a nutshell, that's the basic introduction into matrices. So let's just do one. Plus 2, and let's say x is equal to 2x, and let's say y plus 6. Okay? Now, this one tricks kids, but this is why I like matrices, and I like this problem, because it brings back what we did before in the last section. So if we look here, again, we know that corresponding parts must be equal. So 2y plus 1 must be equal to 2x. And we know that x must be equal to y plus 6. Okay? Because again, the whole point of this was to find x and y. The whole point of algebra is to find missing variables. So kids actually did this today. They came up to me and said, Mr. Flores, this is crazy. I don't know how to do this. This looks insane. But let's think back to the last section, or the last topic we did, and that was a system of equations. We have two unknowns, two equations, so we can solve this, okay? We know that 2y plus 2 is equal to 2x, but we also know that x equals a y plus 6. Well, look at that. That makes our life pretty easy. Because we can just substitute y plus 6 into the first equation, and you're going to get 2y plus 2 is equal to 2 times y plus 6. This is why we never forget past stuff in math class, because it all adds up. When you distribute the 2, you get 2y equals 2y plus 12. All right, subtract 2y, and you get 2 is equal to 12. All right, well, this we're going to do a problem because 2 never equals 12, so, well, our answer is no solution. Okay, there's no way that we can find an x and a y that are going to make this two matrices equal. All right, but we would never have known that if we didn't do all this work. So that's the fun part about math. You can do a lot of work and find out it doesn't actually work. But hey, that's life and whatnot. So basically, what I want you to take away from this video is that a matrix is a rectangular array of data formatted in rows and columns. The dimensions, the way we read them, it goes rows by columns. All right. The second thing is, if we have two matrices that are equal, corresponding parts are equal. So therefore, we know that x was equal to 7, 2y was equal to negative 10, and y is negative 5. If you have two matrices that are different dimensions, your answer is a no solution. And just like when we found out last topic, if you're doing a system of equations and you get a number is equal to a number that's not the number you started with, you have a no solution. All right. So hopefully this video helps you out with matrices. If you have questions, let me know. Again, this is a brief introduction. Matrices are not hard, but some of the things you do with them become very, very computational heavy, to put it lightly. If you have questions, let me know. Check out the website and have a good one.